Okay, this next one we're going to look at is zeros and multiplicity. Okay, so this is going to be the stuff that's happening on the inside of the function. Okay, so we have a lot of really fancy rules here. If f of x is a polynomial function and f of r equals 0, then r is a 0 of that function. Okay, so that's just saying that if I had a function f of x equals x squared minus 4, and say I plugged in a 2, f of 2 equals 2 squared minus 4. Well, that would give me 4 minus 4, which equals 0. So f of 2 equals 0. That means that 2 is a 0. So basically what that's saying is that if I factor these things and I find the answer for it, then that means it is a 0. Okay? The next part says that if r is a real number, then it is an x-intercept. Okay? So we can factor these things to find the x-intercepts. Then next, the last one, this is the more important one probably, if x minus r is a factor of the polynomial, then therefore r is a 0 of f. So basically what it's saying is that if I go down here, if we look at this example, okay, and I factor this function to x minus 1 cubed and x plus 2, the zeros for that function are 1 and negative 2, okay? So we've done this so many times. If I have x squared plus 3x minus 4, I can factor that to x plus 4 times x minus 1, and I solve that for x equals negative 4 and x equals 1. Those are your zeros. So you factor it to find your zeros. Okay, that's all that fancy stuff is saying. Now, along with our zeros, we need to talk about multiplicity. Now, this is new. Okay, if x minus r to the m power, say that is a factor, but x minus r to the m plus 1 power is not a factor. In other words, m is the maximum power possible, then r is a 0 of multiplicity m. All this is saying is that if I have an x plus 1 and an x plus 2 squared and an x plus 1 cubed, all that this rule is saying is I need to make sure that all of my x plus 1s are put together before I say what the multiplicity is. So I would need to make this an x plus 2 squared and an x plus 1 to the 4th power before I talked about their multiplicity. Okay? So, example on this, we're looking at all of your factors. My factors are, if I set each of these equal to 0, 5 equals 0. I don't even need to worry about writing that one. I can't solve it. X minus 2 equals 0. X plus 3 equals 0. X minus 1 half equals 0. Okay? And then I can go about solving these. That gives me x equals 2, x equals negative 3, and x equals 1 half. Okay? I have found now all of my zeros. 2 is a 0, negative 3 is a 0, 1 half is a 0. Okay? Now my 2 has a multiplicity of, what's the exponent that is there with my 2? Well, it would be a 1. 2 has a multiplicity of 1. Negative 3 has a multiplicity, and I'm just going to abbreviate it there, of, what's the multiplicity of negative 3? Well, negative 3 has a multiplicity of 4. So negative 3, multiplicity 4. Last, I have 1 half. What's the multiplicity of 1 half? Okay, well, there's my 1 half factor, and its multiplicity would be 2. Okay, so that is how you find the multiplicity of the zeros. Now, what does that multiplicity tell us? Well, that multiplicity tells us how this function will behave at that 0. And remember, your 0 is just your x-intercept. So how is this function going to behave at that point here? Well, here what I have for you guys is I have a graph, okay? And I've got two x-intercepts here, okay? One of my x-intercepts would be at 1, and 1 has a multiplicity of 2. My other one is negative 2, sorry, and negative 2 has a multiplicity of 3. So I could say that 2 has an even, or sorry, I could say that 1 has a multiplicity of 2, which is even, and negative 2 has a multiplicity of 3, which is odd. Okay? So negative 2 has a multiplicity that is odd. If I take a snapshot and I only look at what is inside that function there at negative 2, that looks like a cubed function. Okay? It's got that same snake shape. What I can say is at negative 2, it crosses that x-axis. Okay? Now, 1, where I looked at it and it was an even function, if I take a snapshot of just what's in there, I could say at 1, it looks like a parabola, which makes sense because even is what results in that parabola shape. So I could say that at 1, it touches. At 1, it touches. Okay? So to kind of summarize this into just a general rule for us, what we're going to say is if R, remember R is a 0, has an even multiplicity, then the graph of f will touch the x-axis at R. Okay? Versus if R is odd, the multiplicity of the graph, f will cross at the x-axis at R. Okay? So first, we had that one that you guys had to memorize, which was your end behavior. This is something else that you'll have to memorize. This will be a question on your test as well. Okay. The last thing that I have for you guys, we'll do it on the last video, is we're going to do kind of the practice problems, which is going to kind of summarize everything that we've went over so far.